Algebra 2, Chapter 11, Section 3, Probability Distributions. A sample space is the set of all possible outcomes in a distribution. We've talked about sample spaces before. It's basically when you take a measurement, it's everything that could possibly happen, or all the possible outcomes, right? We talked about that with the sandwiches and some other stuff. Some distributions are discrete, while others are continuous. And you can see in these two examples here, the sum of two dice, we call this discrete because there are very specific and limited values that you can be. You could be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. There's no way you can roll two dice and get a sum of 24. It just doesn't happen. It's impossible. The biggest number on both of them is 6, and add them together, you've got 12. So you can't roll a 24. And they're assuming standard dice for this one. Obviously, you could have like a 12-sided die, and that would change it. But when they're talking about this, unless they say otherwise, they mean a 6-sided die. A continuous distribution is something like miles per gallon. Now, you can have a truck that has 19.2 miles per gallon, and you could have a truck that has 19.3 miles per gallon. And you could also have those same two trucks if you have a different measuring device that lets you be slightly more accurate. It could have been 19.21 and 19.27. Or you could have gone down even further. And the idea is there's the limitation of how accurate you are in your measurement is just whatever tools you're using, but it can always be taken down further. And you can see it's all the stops in between. Decimals are okay, where in the discrete area, there's always gaps between the results. Now, decimals can be okay here, but there's still a gap between the decimals, if that makes any sense. Okay, but that's the idea between discrete and continuous. So a value of a random variable is the numerical outcome of a random event. A random variable can be discrete or continuous. We talked about that there. Discrete random variables represent countable values. That countable values idea is basically there's 11 things that can happen. That's it for the sum of two dice. 11 options. That's all you got. Continuous random values you can take on any value. That's what I was talking about here with the continuous. Since it's everything in between, you get all the decimal places that you want. So let's go ahead and take a look here and see if we can tell some continuous and discrete examples apart. Example 1, identify and classify random variables. Identify the random variable in each distribution and classify it as discrete or continuous. Explain your reasoning. A. The number of songs found on a random selection of MP3 players. So to me it looks like the random variable is random songs. A number of songs, I should say. Number of songs. I could have an MP3 player with 20 songs on it. I can have an MP3 player with 500 songs on it. Can I have an MP3 player with 20 and a half songs on it? No, not really. I mean, I either have a song or I don't have a song, and it doesn't like you don't get half of a song, right? So here this would be discrete because I don't know if you've seen that before, but the B/C is the shorthand for because. You can't have half a song. Now, I guess you could if you only recorded half of the whole song that they did, but it would still be a whole song file on it, even if it was only partial. or it just wouldn't even play. The weights of football helmets sent by a manufacturer. So the random variable here would have to be weights of helmets. And this would be continuous, because there can be slight variations in each helmet. And if you want to get really tricky with it, the tool can measure things more accurately. Like if you got a tool that only measures to the gram, that's going to look discrete until someone pulls out a tool that allows you to measure it to the nearest hundredth of a gram. And now it looks a little bit more continuous. So that's the idea there. All right.